Welcome to the Logic Gate. How is a chip designed? Have you ever wondered how a chip is designed from scratch? Not a microcontroller you buy at a store. I mean the actual chip, the silicon. How do engineers go from an idea to a piece of hardware that runs at gigahertz? It all starts at level called RTL. In this video, I'm going to explain what RTL is, why it exists, and how it fits into the ASIC design flow. In this first video of a full playlist, we are going from zero all the way to understanding a complete chip design flow. Hardware is not software. Before we talk about RTL, we need to clear up something up. When you write code in Python or C or any programming language, you are describing a sequence of steps. Do this first, then do that. If this condition is true, go here, otherwise go there. It's sequential, one instruction at a time. Hardware is completely different. When you design a digital circuit, you are not writing a list of a step. You are describing a physical structure, a circuit that exists in silicon. And that circuit operates currently, in sync with the clock. Every signal, every gate, every register, all of them react on every clock edge. There is no interpreter running your code. There is no CPU deciding what to do next. The circuit just is, and it does what it does every single cycle. So the question becomes, how do we describe a circuit without drawing every single transistor by hand? That's exactly the problem RTL solves. RTL stands for Register Transfer Level. Is the abstraction level we use to describe digital hardware in a way that can be synthesized into an actual circuit. There are two fundamental building blocks in RTL: sequential logics, that could be register, flip-flops, state machines, and counters. Combinational logics could be adders, multiplexer, AND gates, or just comparators. Here is how they work together. You have a register, a flip-flop, that hold a value. When every rising edge of the clock, that register capture a new value. Where does that the new value come from? From combinational logic. The combinational logic take the current register value, does some computations, and produce the next value. That is RTL, data moving from register to register, transformed by logic, synchronized by the clock. Every piece of digital hardware, from a simple counter to a full CPU, can be described by this way. How do we write RTL? So, how do we actually write RTL? We use what's called a hardware description language, an HDL. The two most common ones in the industry are Verilog and SystemVerilog. There is also VHDL, which is more widely used in Europe and in the defense industry. In this channel, we are going to use SystemVerilog. It is the modern standard from ASIC design. Now here is something that trips up a lot of people coming from software. These are not programming language. When you write an if statement in SystemVerilog, you aren't telling the CPU what to do. You are describing a multiplexer, a physical piece of hardware. When you write a plus sign, you are inferring another circuit. Every line of RTL code corresponds to actual hardware that will be built in silicon. The mental shift from thinking in sequence to thinking in hardware is the most important thing to internalize. The ASIC design flow. Now, let's zoom out and see where RTL fits in the full ASIC design flows. It all starts with RTL, the SystemVerilog code we just talked about. From the RTL, a tool called Synthesizer takes your code and convert it to a netlist. A netlist is a description of actual logic gates and how they are connected, and gates, flip-flops, multiplexer. From the netlist, another set of tools does the place and route. This step takes the logics and physical place them on the chip, the route the wires between them. The result is a layout, the exact geometric shapes that defines the chips in the silicon. The layout goes to the semiconductor fab and they manufacture the physical chips. RTL is where it all begins. If the RTL is wrong, everything downstream is wrong. That's why RTL design and verification is one of the most critical skills in the ASIC world. Alright, now you know what RTL is and why it matters. In the next video, we are going to write our first actual RTL model in SystemVerilog. We are going to build a simple 8-bit counter, the hello world of RTL design. You will see what always underscore FF blocks look like, how reset works, how the synchronization looks in the real code. And we are going to simulate and its look at the waveforms. If you want to follow the full RTL Flow ASICs playlist, just subscribe and hit the bell. Any questions, drop them in the comments. I read all of them. See you in the next one.